We're going to go ahead and take a look at simplifying algebraic expressions today and also factoring. Now, first of all, down below here, we have one equation, we have one expression, but which one is which? Well, the first one is an equation because it has an equal sign in it, so it's an equation. The second one has no equal sign, so we refer to it as an expression. Now, can we actually solve an equation and find the value of x? And the answer is yes. Can we actually solve expressions? And no, because they're not equal to anything. So down below here, we have what's referred to as a polynomial. More specifically, it's a trinomial because it's three terms. Terms are things added and subtracted together. Our constant is the one term that doesn't depend upon anything with x. So our constant is the 2. Our variable is our x. Coefficients are the numbers in front of your variables, in this case the 5 and the negative 7. So therefore your leading coefficient would be the term in front of your highest power. So that would be our 5 because it's in front of your highest power of 3. Your degree, the highest power, is 3. So polynomials are like what we just looked at, one or more terms added and subtracted together. But the exponents in the variables can either be 0 or positive integers, meaning natural numbers. You cannot have variables multiplied together, and you cannot have variables in the denominator. So, is each one of these a polynomial, yes or no? If no, why? The first one is not because we have a variable in the bottom. The second one is not because we don't have whole number exponents, because a fractional exponent would put a variable in a root. Hence, this one's not a polynomial either because you have a variable in a root, which is a fractional exponent. And our exponents and polynomials, according to what it says up here, have to be natural numbers. This one over here, it is a polynomial. Yes, we have a root, but this root is only over a number, not a variable. So it's several terms added or subtracted together with only positive whole number exponents. So yes, it is a polynomial. So with polynomials, we can go ahead and simplify them. And so simplify means eliminate parentheses and combine like terms. Well, as we look at this first one, the first set of parentheses aren't doing anything. The second one, we'd actually have to distribute the negative through to each one, and then we could collect like terms. Like terms are those that have the same variables with the same exponents. There is only one cube, so we'll just bring that down. But here you'll see we have negative 2 of the x squareds, and we're subtracting 8 more of the x squared, so that's a negative 10 of the x squareds. Then you have one of the x's plus another one of the x's, that's a 2 of the x's. And then you have minus 2 and plus 2, they cancel, so this is what we get. Simplify means eliminate parentheses and combine like terms, and that's what we did here. Over here in this one, we'd want to go ahead and deal with multiplication here. 2 terms times 2 terms, we would FOIL, multiply your first terms, outer terms, inner terms, and last terms. Over here, you have 3 things multiplied together. The order in which you multiply doesn't make a difference. I'm going to choose to multiply the 2 parentheses together, so I'll leave the 7u in front. And then I just have to FOIL these 2, first terms, outer terms, inner terms, last terms. Now here I can combine my like terms of what's in orange, 5 of the u's minus 1 of the u's. Bring down my 3u squared, bring down my minus 2. Over here I'll bring down my 7u, and you'll notice here my 1u and my minus 1u cancel, leaving me only with the u squared and the minus 1. Nothing I can do here, I'll bring that down. Now I got to take my 7u times both of these terms. So 7u times 7u squared is a 7u cubed. 7u times minus 1 is a minus 7u. Now I can combine together my like terms. I only have one cubed, I'll bring that down. I only have one of the squareds, I'll bring that down. But you'll notice I have 5 of the u's minus 7 of the u's, and that's a minus 2 of the u's, and then bring down my minus 2. Now, here we need to simplify. Notice we have subtraction on the top. However, you guys are used to taking two fractions like this with the same denominator and writing them as the numerators over that one denominator. We have this over one denominator. Yes, it has three parts, but it's one denominator. So we could take each term on top over our denominator. The first term on top over our denominator. Second term on top over our denominator. So now all we'd have to do is go ahead and do a little bit of simplifying. You'll notice with each fraction, a z times the top, z times the bottom. X times the top, x times the bottom. And here, which one has more y's? The top does, one more. Here, which one has more y's? Well, they are the same, they're going to cross out. And then we could look here, which one has more x's? The top does, one more. Which one has more z's? The top has two more. And then you just work with what's left. You have a 6xz squared minus a y. Don't really need to have it over 1, so we can just write that. This top right one, there's a couple ways we can do that problem. We could go root x plus root y times another root x plus a root y because it's squared. We could take a root x minus a root y times another root x minus a root y because of the squared. Some of you might be tempted to bring the squared into each one, but remember we can't do that when there's a plus or minus on the inside. We really just have one thing squared times another thing squared, just like an a squared times a b squared. That could be written as an a times a b and then square the whole thing. So we could do it like I mentioned first, or we could pull the squaring on the outside and then just multiply together what's. So we'll go ahead, we'll multiply the first terms. Root x times root x would be a root of x squared, or x. Outer terms would be this. Inner terms would be the same thing but positive. Last terms would be a negative this. Combined together are like terms. Notice the red and the green cancel, leaving us only with an x and a minus y. Then we still have to do our squaring. So squaring means multiplying by itself. So x minus y times another x minus y. Then we FOIL our first terms, outer terms, inner terms, last terms. Combined together are like terms here in the center. Negative 1 of the xy's and another negative 1 of the xy's is negative 2 of the xy's. Bring down your x squared and bring down your y squared. So see if you can go ahead and do this one. Notice this whole thing here squared means multiplying it by itself. So we'd have to take this x squared times each one of these three, this x times each one of these three, this 1 times each one of these three. So x, looking at the red, x squared times x squared times the x squared times the 1. Looking at the blue, this x times your x squared, x times the x, and then x times the 1. And then looking at the purple, the 1 times each one of these. Well, multiplying by 1 doesn't change it. Now we can go ahead and combine them together like terms. Bring down our x to the fourth. We have a 1x cubed, another 1x cubed is 2 of the x cubes. An x squared, another x squared, and another x squared is 3 of those x squareds. Then we have a 1x and another 1x, which is a 2x, and we have a 1.